Hello friends, let us do an important problem today from your engineering mechanics which is useful for all your examinations, be it AE, AEE or AMVI, right? This syllabus is included. So if we go through the problem, find the magnitude and direction of the resultant of two forces F and root 2F acting on a particle with an included angle of 135 degrees between them. This is a very interesting problem and tricky problem, right? Let us see how to solve this. So let us draw a figure. Let me draw a figure. This is your what you call P. This is your Q. These are the two forces. Okay. So now the angle between them is 135 degrees, right? 135 degrees. Now he is asking the magnitude and direction of the resultant of two forces, right? So this, let us say this is my resultant, okay, right? So this is the angle theta. So theta is the angle made by the resultant with the direction of P, right? So if I complete the parallelogram and all those things, right? So this will be your Q sin theta, Q sin alpha, and this is your Q cos alpha, right? This is your Q cos alpha and this is your Q sin alpha, and this is Q cos alpha, right? So totally P plus Q cos alpha, and here you have Q sin alpha, right? So now let us say alpha is the angle between them. So we know that the resultant of the two forces, okay, between which the angle is, let us say this is your P, this is your Q, and this is your alpha. We know that resultant formula is equal to, this is given by R is equal to under root of P square plus Q square plus 2PQ cos alpha, right? So substituting, so it is given that P is equal to F and P is equal to F and Q is equal to root 2F, okay, right? So if I square P, I will get F square. If I square Q, I will get 2F square, right? Substituting that, so R is equal to under root of P square plus Q square plus 2PQ cos alpha, right? Substituting, R is equal to P square means F square, Q square means 2F square, and 2 into P is F and Q is root 2F into cos of the angle between them, which is nothing but your 135 degrees. So you know that from our trigonometry, that what do you know? So from the trigonometry we know that this is your okay, all silver teacups. This is your all silver teacups. Okay, fourth quadrant, third quadrant, second quadrant, first quadrant. First, this is your first quadrant, this is your second quadrant, third quadrant, you know that this is your fourth quadrant, right? So in the second quadrant, this is your 135 degrees, right? In the second quadrant, your cos is minus. Okay, I can write cos 135 is equal to cos 135 is equal to cos of 180 minus 45, right? So because this comes in second quadrant, cos of 45, but it is minus cos 45. So cos 135 is equal to minus cos 45, and cos 45 is equal to 1 by root 2. This you know that, right? So let us go further. So substituting that, F square plus 2F square into 2 into F into root 2F into cos of 180 minus 45, that is your, sorry, yes, I am writing cos 135 is equal to cos of 180 minus 45, that is minus cos 45. So cos 45 is equal to 1 by root 2. Substituting that, I will get R is equal to under root of F square plus 2F square minus 2 into F into root 2F into cos 45 minus, it is included here before that, okay, before 2F. Okay, so 1 by root 2 cos 45 is equal to 1 by root 2, root 2 get cancelled, and I am going to get F square plus root of under root of R is equal to under root of F square plus 2F square minus 2 into this root 2 get cancels, F into F, that is means 2F square. So R is equal to under root of 3F square minus 2F square, that is under root of F square, that is F. Okay, so though it is very simple one, I am explaining because some of you may be, okay, might have forgot the formula, whatever it is, right? So I am explaining from the basics. Okay, now the angle between the resultant, so let us draw the figure once again. So this is your and this is your, let us say, resultant, this is your resultant, this is your theta. Okay, cos theta is equal to given by, sorry, tan theta is equal to given by, you know that it is Q sin alpha by P plus Q cos alpha, right? So let us write down Q cos alpha. Okay, write down. Right, so substituting that, theta is equal to tan inverse of Q sin alpha by P plus Q cos alpha. Substituting that, theta is equal to tan inverse of q is equal to root 2 f. We have seen already. Okay, it is given. Sin alpha is equal to sin 135. P is equal to f. Q is equal to root 2 f. And cos alpha cos 135. You know that cos 135 is equal to minus 1 by root 2 or minus cos 45. Substituting that, I will get tan inverse of root 2 f into again sin 135 is equal to, it is sin 45 only, because sin is positive in the first quadrant. Okay, sin 180 minus 45, nothing but sin 135, that is nothing but because it is in the first quadrant, we will get sin 45 is equal to 1 by root 2. So 1 by root 2 f into 1 by root 2, it is going to be f, and f plus root 2 f into cos 135 is equal to minus 1 by root 2. So that root 2 get cancels, minus f I am going to get. So theta I am going to get tan inverse of f by f minus f, that is equal to f by 0, something by 0, you know that it is all infinity. So tan theta is equal to infinity. What you got it? So tan theta you have got it. So what is this theta is giving? It is giving the direction of the resultant with the direction of the p, force which is horizontal. Tan theta is equal to, I got something by 0, okay, some x by 0, whatever it is, I am going to get f by 0, f by 0. So let us say f by 0, that is nothing but infinity. So tan in theta is equal to tan theta is equal to infinity. So tan inverse of infinity, tan theta is equal to infinity. So tan theta is equal to, so theta should be equal to 90 degrees, right? So because sin 90 is equal to 1 and cos 90 is equal to 0, 1 by 0 is equal to infinity. This is your tan theta. Tan theta is equal to infinity, means theta should be equal to 90 degrees. So the resultant we have got it. So this is a very interesting problem, boys. So if you have seen that, it is nothing but the resultant is nothing but your q only, right? P is f, sorry, p only, horizontal force only, right? So it's very interesting. So your the resultant is horizontal force only, and the angle between the resultant, that is the angle the resultant is making with the what you call direction of p is nothing but your 90 degrees. So your diagram will be something like that, right? Right. So theta is equal to 90 degrees. This is your root 2f, this is your f, right? So this is your alpha, right? Theta will be equal to 90 degrees. So resultant will be making 90 degrees with the direction of f, okay, something like this. So you will get, you will be like this, right? So this is your resultant, okay, all right. Let me draw it once again. Okay, so this is here, it is something like this, right? This is your theta, this is your alpha, this is your f, this is your root 2f, and this is your resultant, this is your theta. So theta is equal to 90 degrees. So direction of the resultant is 90 degrees with the direction of f, and its resultant, okay, so resultant force is equal to, it is f only, it is something like this, okay. So it will be something, so how it should be, so resultant should be like this only, resultant will be along the direction, okay. Let me draw the figure once again. It will be something like this, right? This will be like this, this is f and this is root 2f, and this itself is the resultant, okay. So both the, this is your, this is your yes, let me draw it once again, right? This is your resultant, okay. So in this problem we have seen that the resultant is equal to f, and the angle between the resultant, okay, and the direction of f, which is nothing but your we have assumed that p is equal to f, okay. So that will be equal to 90 degrees, okay. So once again, let us meet in a very good video, boys. If you like my channel, please like, subscribe, comment and share among your groups and contacts. Thanks for watching, and if you are looking or if you are watching my channel for the first time, please subscribe and support me. All the best, good luck.